what an angle is. What's an angle? What's an angle? What's a definition of an angle? So we learned about the undefined terms, and we learned about some definitions of some other things. Like we learned about points, rays, segments, lines, stuff like that. Who can give me a definition of an angle using some of those other words that we had in the last chapter? Yes, sorry. Don't tell me. Who's that? That is Maddie. Maddie. What's the definition of an angle?
It's formed by two rays.
Very good. Okay. It's formed by two rays. So what Maddie said, it's formed by two rays. That's not very good. Let's undo that. Let's try again. So it's formed by two rays. So first I have to make a ray, right? And I'm going to do it with a solid line. I'm going to make it go in one, let's do this. So here's a ray, right? Yes? And here's another. Is that an angle?
Yes.
It is? Where? Where's an angle?
There's two angles.
Oh, see that? What angles? Where? So it's 2, it's 4. So it's, can you refine your definition a little bit? How can I make it look more like an angle? How would I do that?
Erase the other line.
Ah, wait, who's about to say something intersect? Two rays intersect. What were you going to say there, James?
He said two rays intersect with each other.
Where?
At the end.
That's just about right. Okay, two rays that intersect each other at the same point. Would you agree with that? Okay, so an angle is two rays, the way they define it in the book, two rays that share a common endpoint such that the rays are not collinear. Okay? Let me move this a little bit because I don't like the way. Can I move this? Ah, look at that. Okay? There we go. And let's put a pointer just to make sure. There we go. So an angle, sorry, it looks like I'm writing in a foreign language up there. Okay? Is two rays. Sure. Common endpoint. And they're not collinear. Whoops, I think there's two L's involved. Okay, why can't they be collinear? If they're collinear, what would it look like?
Because it wouldn't be an angle.
Yeah, if they weren't collinear, if they looked like this, right? Then what's wrong? If they're collinear, then what's wrong?
They're still flat.
Yeah, it's flat, so it's just like a straight line. So they have to be an angle. Okay? So that's a good definition of an angle. We name an angle in several different ways. So you can name this point right here. Anyone know what this point right here is called?
Midpoint.
Not the midpoint, that's for a second. Someone else, what's this called? Vertex, yes. This is called the vertex. These are called the sides. So here's a side. This is a side. Over here, just so you know, this is called the interior of the angle, the inside of the angle. And when you name an angle, you name it usually by 3 points, right? With the vertex in the middle. Do you know that? You know this already? And the way you abbreviate it is angle, and it looks kind of like an eye. They don't use this little curvy thing in the book, but otherwise it looks like less than signs to me. So this is angle ABC, or angle CBA. You can't name it BCA because that implies that the vertex is over here. Okay? If there is only one angle here, there's no ambiguity about it, meaning it's clear which angle you're talking about, then you could just call it angle B, just by its vertex.
So
right?
like vertex, like it's always in the middle.
Exactly. The vertex is like always in the middle. Yeah. Wow. Fantastic. Isn't that amazing? Sometimes, if the book, or if I want to name an angle real quickly, sometimes I'll put like a 1 there and I'll say this is angle 1. Okay, but for the most part, you name an angle by letters. But make sure that you put the letter of the vertex in the middle, and if there's no ambiguity about it, meaning it's there's no confusion, then it's like this. But if I said, here's angle B, right, I don't know which angle you're talking about. You know what I mean? So say if I call this, so who can give me another name for angle, what's another name for angle 1? Very good. We know ABD. What's another name for angle 2?
CBD.
CBD or DBC. Okay, and so on. Okay. So you can name it angles in a bunch of different ways. All right. The measurement angle. So next, almost the last thing. The measure of an angle. I don't know what the measure is. It is the smallest rotation. So rotation. Ray, it should say ray. Ray to another. So, for instance, here I'm going to make an angle. So I'm going to take my angle, this thing, and I'm going to take this thing. Where's that thing? Up here. Watch how high-tech I am. Okay? Protractor. 180 degrees. There now I have the protractor. Isn't that cool?
Yeah.
Okay? So, if I want to measure this angle, and I'm going to show you how to do it, I'll put this over here. Do you guys have, we're going to practice a little bit, okay? So I put my protractor over here, and then I take one of the edges of my protractor and I line it up on one side of my angle. It doesn't matter if I put this over here or if I put that over there. Oh, whoops, that didn't work, okay? I want to make sure that this goes and lines up here. And 0 always lines up on the 0. Got that? Okay? So the smallest rotation from one side to another, from here to here, is approximately how many degrees?
40.
40 degrees. So you guys probably, I know you've used protractors before because my daughter's in 8th grade and she was doing it last year, right? And so if it's on the inside scale, you start at 0. If you always start at 0. So if I want to measure from here, I start 0, 10, 20, 30, 40. Now the other way I could have done this is lined up my protractor. Let's see if I can do that. Okay, take my protractor. I could have lined up this side, even though it wouldn't have made much sense. I could have been this side over here. See that? So that's on 0. And then I would have started from here and use the outside scale, and I still would have gotten 40. I think I could take this little piece and line it up this. Oh no, I grabbed here. That's what I did. Look at this. Technology at work. Okay, so I would start here and go from 0, and that angle would be 40.
So, like, are you like chill with like the protractors in class? Like, there's like a certain limit where you can get that angle off, because like I know some teachers aren't like.
Oh yeah, I'm not gonna give your degree or two off.
All right, so some
Yeah, I'm
teachers
not
aren't
gonna.
chill about that.
Chill. I guess I'm chill. Chill. I'm chill with
You'd
that.
be super chill if you let me
Okay.
sit back here.
So I showed you how to do that. Always start 0 except the raise. Subtraction, I talked about that. Naming angles, I talked about that. Just a couple more quick things. Sometimes, if you have your protractor, let's get it back to normal. Let's get it back over here. Move it back over here. Sometimes they'll give you a little teeny angle. So they'll say, oh, measure this angle. And you go, my angle doesn't fit on there, right? My protractor doesn't fit. So what do I do?
Make it bigger.
Yeah, you extend it. You take your ruler and you extend those sides, all right? So if it's kind of too small, you're going to take your ruler. I don't need a ruler. I could just use this thing. And I could make them longer, right? I could extend on using a ruler or something. Then I could go back and I could measure the angle. So I did. Okay, here we go. And then be back in like 3 minutes. Okay. How do I get rid of this? Close it. Congruent angles. Are angles that
What does it mean?
So say I have two angles, one that looks like this and one that looks like this, and you measure them and they come out to be the same. So say this, the way you indicate congruent angles, so it's with the mark there and a mark there. And so in this case, I'm just going to name them by A and B. So I would say that angle A is congruent to angle B, which implies, okay, that the measure of angle A is equal to the measure of angle B.
Is that
So
an N?
what?
The equal sign?
That's an M. That means measure.
No. Angle A is like up.
The end above the equal sign.
That's a congruent symbol. So it's an equal sign with a little squiggle on top.
It's a split.
So if those two things are congruent to each other, then their measures are equal. So if you say, so you have a polygon. Okay, let's draw a polygon. I'm going to use this tool. Okay, this is one of my favorite tools. You're going to be really impressed with this one. Watch this, Julio.
Yeah.
Watch this.
Is it cool?
Isn't that
Wow, they're so good.
Okay, so I'm so chill.
You're so
Okay,
chill.
so there's this here, there's this here, okay, and this and this, okay. So here's A, B, C, D. What can you tell me about angle A?
Obviously has a.
It's good. It's congruent to angle C. All right, and angle D is congruent to angle. Hello.
So what are we doing?
Angle D is congruent to angle what?
B.
B, okay? So if there's more than one set of angles, usually they indicate it like these two go together because they have one hash mark, these two go together because they have two hash marks. And say I know that the measure of angle D is 70 degrees. What is the measure of angle B? Whoops, measure of angle B. What's that?
70 degrees.
Measure of angle B is also equal to 70 degrees. So one thing you can't really say is that the measure of angle B is congruent to the measure of angle D. That would be incorrect, just like it is with segments, because measure implies it's a number, okay? And when you're talking about congruence, you're talking about a set of points. So when you say congruence, it means, hold on a second, it means that this angle is the same, has the same measure as this angle, but it doesn't mean that they're equal in numbers. This means equal in numbers. So this would be kind of a, you get a point or two off for saying something.
Wait.
like that.
So while it's gone, we're just like discussing like congruent angles. And
Yeah. You can watch the video. Huh?
What?
Yeah. Cutting edge. All right. So last thing I talked about, well, two last things, is an angle bisector. Angle bisector, pretty easy. Angle bisector, what's an angle bisector do? Yes. Angle bisector? I'll give you a hint. Okay? They looks like this.
Splits it.
Whoa.
Makes it two angles.
And if this is, let's call this X, let's call this Y, let's call this W, let's call this Z over here, okay? XZ is an angle bisector of angle YXW, even though usually they go in order, okay? But an angle bisector is what is an angle bisector? What type of, what?
Segment.
It's not a segment, it's a what? Array. So that goes through the vertex, goes through vertex, and divides, that's a 9. Divides an angle, well, I'm having trouble. Angle into two congruent, this means congruent because I'm going to use abbreviations, congruent angles, not parts, but angles. Where? This?
Yeah, the
Congruent. No, it's just a squiggle above the equal sign. Okay? So an angle bisector is a ray. So you would say that XZ, ray XZ, is an angle bisector of angle YXW. Okay? So that means that these two angles are congruent. So that makes, so I might write angle 1 is congruent to angle 2 because, or you might conclude, maybe they'll give you angle 1 is congruent to angle 2. What can you conclude about XC? What? That's about it.
Don't give it, can I just?
Yeah. Sure. I'm just going to tell you one very last thing, and that'll be the end. Okay. I've been talking for. So the last thing they talk about is this thing, pool room math, and it's just kind of a basic property of physics, really. And that's that if you have, like, any of you guys play pool?
Yeah.
Any of you guys play pool or what other basketball players and stuff like that? Okay, so pool room math and basketball, kind of the same idea here. If you, or lots of sports where there's things bouncing off of other things, or lots of video games like this, what it says is that if you bounce something in at some angle,
See, that's off the other.
it bounces off at a congruent angle. So if something comes in this way at an angle, say at 45 degrees, when it hits that wall, it's going to bounce off at exactly the same angle. All right? Okay, and that's the way light reflects. That's the way if you playing pool, you know, they say, oh, he figured out the angles and all that kind of stuff. So the master pool players, they know, well, if I bounce it off this cushion, it's going to go into this pocket over here. But sometimes they figure out a couple different things. But the angle coming in is equal to the angle coming out. So in tonight's homework, they're gonna ask you, okay, this pool ball comes in at this angle, where is it going to end up, or something like that. And you have to copy. You have to make a copy of the angle and measure it there. And that's about it. Okay. So I think we're done here. Your homework is homework. No, but you can start on your homework. Okay. It's page 42. That's not very good. Homework, and you can borrow a protractor from me for today. Homework, page 42. 2 through 40 evens. A lot of them is just naming angles and measuring things. And then I have a little extra section on symmetry, which you could read about. Page 4. Page 4. 1 through 6. Okay? And that's about it. Okay? So I'm going to stop this video. And remember, you heard it here on the Leader's Edge Math channel. Okay?
Yeah.
Yeah.